Here let us discuss a problem of rotational dynamics, and it is useful for JEE Advanced only. In this problem, it is given that there is a light, rigid, right-angled frame OAB. These sides are each of length L, and at the junction A particle of mass m is attached, and at this end B, another particle of same mass m is attached. This point 2 is hinged. When this side is vertical and this is horizontal, this frame is allowed to rotate from rest. Immediately after that, we have to find what will be reaction of this hinge on this frame in horizontal direction and in vertical direction, right? तो इस प्रॉब्लम को सॉल्व करने के लिए what we should do, we should find the acceleration of these two particles somehow with magnitude and direction. Then applying Newton's second law on this whole frame in horizontal direction and vertical direction, we can get the reaction by the hinge. To find acceleration of these two particles, we should realize that this is a rigid body. And if there is a hinge in the body if allowed to rotate, it will try to rotate about hinge if there is some torque. तो यहाँ पे torque available है. There is a torque available about this point due to weights of these two particles. So we will first apply the relation torque about 2 equal to I about 2 into alpha. We can apply it because O is a hinge point. It is allowed. And after we find this angular acceleration, we can find the accelerations of these two particles because they will rotate in circular path. This will rotate in circular path of radius L, and this particle will rotate in a circular path of radius L root 2. So from that we can find their acceleration. So first let us find alpha. To find alpha, let us find the torque. Torque about O. Torque about E will be due to weight of B only, because weight of A will pass from O. It will not produce any torque. So that is 0. Plus torque due to B will be, I think, simply mgl, because this weight have line of action this, and on this line of action we will drive perpendicular from here. This will be L, and the torque due to weight of B will be mgl. So overall torque about 2 will be mgl. What is I about 2? I about 2 is simple. This particle will have I about 2 ml square, and this particle will start rotating in a radius L by 2. So its I will be m into L root 2 square, mr square. So ml square plus m into L root 2 ka square. And frames, these sides have no mass. These have no mass, so they will not contribute anything in I. So we will find I about 2 as 2 plus 1, 3 ml square, right? So alpha will come out from this relation, torque upon I. The mgl upon 3 ml square, alpha will be g by 3l, right? Now let us focus on this particle at A and particle at B. We know that when a particle rotates in a circle of radius r, it has, suppose there is some particle rotating in a circle of radius r, it has two acceleration, omega square r towards center, and r alpha, that is alpha is angular acceleration, tangential. Tangential means perpendicular to radius. Since the system is just allowed to rotate, there is no omega. Omega is 0. So each of these two particles will have no centripetal acceleration. They will have only tangential acceleration, means acceleration perpendicular to radius. So this will have acceleration in this direction, that is r alpha, that is L alpha. And this particle B, particulate B, will have acceleration r alpha. So r is here L root 2, right? L root 2 into alpha. So I am drawing here particle A and particle B. Particle A will have acceleration like this, L alpha, and this L alpha will come out to be, from here we can say L alpha will be G by 3. And this particle at B, here I have explained, will have acceleration L root 2 alpha. L alpha is G by 3, so this particle will have acceleration in this direction, G by 3 root 2, right? And here somewhere we had O point, and this acceleration will be, this angle will be 45 degree. This is also 45 degree by this given data, L, this is 90. So let us apply Newton's second law on this whole system of two particles. If we consider force by the hinge, I2, suppose hinge is applying force on this frame, F1 in horizontal direction and F2 like this, F2 in upward direction. Another forces are weight of this particle, mg, weight of this particle, mg, and weight of particle at B as mg. So we have four forces. Two are unknown, mg, F1 and F2. Let us apply Newton's second law on this whole frame in horizontal direction. In left direction, I will say. In left direction, forces applied are only F1, right? So F1 should be summation of mass of each particle and acceleration of each particle, corresponding particle in horizontal direction. So first particle is say at a m, and this particle has acceleration leftward g by 3, so it should be g by 3. And particle at B also have some leftward acceleration, g by 3 root 2 cos 45. तो cos 45 करेंगे तो 1 by root 2 कट जाएगा, बचेगा क्या, g by 3, and mass का m है. So here also we will get mg by 3. So F1 we have obtained, that is 2 mg by 3, right? 2 mg by 3. And to one part, that is horizontal reaction by hinge, we have obtained this one, 2 mg by 3 in left direction, as like this here. This is 2 mg by 3. This is one answer. And now we have to find vertical reaction by the hinge. So let us apply Newton's second law on the whole frame in vertical direction. Vertical direction we have forces F2 upward, mg downward. Since we are observing that here we have downward component of forces here, downward accelerations, this will have downward acceleration, this will have no vertical acceleration. So applying this concept that on any system, force in any direction, say vertical direction will be equal to mass of first particle into acceleration of first particle in vertical, mass of second particle into acceleration of second particle in vertical. The same relation which I have explained here, used here. So for many particle system, we apply Newton's second law in this form. force in any direction on any bigger mass system will be equal to mass of each particle into acceleration of that particle in the direction of applied force. So vertical force we have F2 upward, mg downward. So let us apply Newton's second law in downward direction. I think there are accelerations in downward direction, so it is better to apply downward direction. Newton's second law, 2mg minus F2 is the net downward force on the system. And what is acceleration of first particle in downward? It has horizontal, so no downward acceleration. So for first particle we will have 0 here. For second particle we have mass m, and vertical acceleration will be g by root 3 into root 2 into cos sine 45, right? So it will be g by root 3 only. So m g by 3 root 2 into 1 by root 2, so there will be mg by 3. So F2 equal to 2mg minus mg by 3. This will be 2mg minus mg by 3, right? 6 minus 1, that is 5 mg by 3. So finally our answer is here. Hinge will have reaction leftward and upward. How much? Leftward we have just obtained earlier. That was, yes, F1, 2mg by 3. This was 2mg by 3. And just now we have obtained F2 as upward 5 mg by 3, right? Here one relation which I used, I will explain once more. When we have many particle system connected, then external forces on this system in any direction, say in x direction, external force will be equal to mass of first particle into acceleration of first particle in x direction, mass of second particle into acceleration of second particle in x direction, like this. And similarly, force in y direction, external जो भी लगा है, that will be equal to mass of first particle into acceleration of first particle in y plus mass of second particle into acceleration of second particle in y direction. So this is a very powerful relation which normally people don't use, but it's better to use in case of many particle system. Like here I have considered these two particles as a part of system, and external forces are hinge forces and these two weights. The frame forces जो कि particle पे आपस में लगते हैं, that is internal force, right? So using this concept which I explained here, I have considered Newton's second law for this system in horizontal direction and in vertical direction, right? First I obtained alpha, then their accelerations, and then applied these two relations in horizontal and vertical direction. तो horizontal reaction आना चाहिए 2mg by 3, vertical आना चाहिए 5mg by 3, right?